Okay, do we want to go ahead and get started?
Sure, let's go ahead and get started, Eric. So,
Okay, I'll let you.
yep. Thank you everyone for joining us today. My name is Jim Gumpert. I'm the Chief Commercial Officer for High Fidelity Genetics. And thank you so much. We recognize that time is everyone's most valuable commodity these days. So we are going to be as efficient and as effective as we can on our webinar today in passing along some very exciting information about High Fidelity Genetics. And just a couple of housekeeping items. Everyone is in mute mode for now, except the panelists, and you'll be turned on during the Q&A session a little later in the webinar so that you can ask questions. And if you need to, you can pass along a note in the chat box, and Eric will be monitoring the chat box. So with that, Eric. So we're going to talk a little bit about our agenda today. Our agenda is a quick introduction to High Fidelity Genetics by myself. And then we'll have Dr. Philip Benfey on. Philip is one of our co-founders, and he'll talk about our root science and root tracker research that we have ongoing today. And then Dr. Bill Niebuhr will come on and he'll talk about our HFG non-GMO product lineup and some of our key products that we're featuring. And then we have Mr. Ben Adolph on from Merge Organics. Ben is one of our customers and growers and has had some great experiences with our products, and he'll share some information about our products on his farm. Then we have a quick Q&A session scheduled after that, and then a quick wrap up at the end. So just a couple of comments about the company. High Fidelity Genetics was founded in 2014 by two plant geneticists, Dr. Philip Benfey and Dr. Spencer Maughan. And the company was really founded around taking industry-leading plant genomics and combining those with some machine learning and artificial intelligence to understand below ground root biology and bring new solutions to farmers. And that's really what we're all about. Our team brings together essentially decades of agriculture and farming experience, plant breeding and genetics, root biology, data science, and seedsmanship. And we are bringing those disciplines together to improve overall yield, agronomics, and quality for growers. So our agenda today, as I mentioned, is going to be kicked off by Dr. Benfey. Dr. Benfey brings decades of root biology experience to the table. He is one of our co-founders along with Dr. Maughan. So please welcome Philip to the agenda.
Thank you so much, Jim. Well, welcome everybody. And just want to give you some highlights about our work on roots at High Fidelity Genetics. We think that roots are a pretty important part of the plant, but one that's been pretty much ignored. But for crop resilience, for drought tolerance, for a whole host of things, roots really need to be put back in the spotlight. And the way we're doing that on the next slide is with a device that we call the root tracker. This is a device that is able to monitor root growth in the soil over time. Its key components are down in those green paddles below. Those are printed circuit boards, and embedded in them is a series of capacitance touch sensors. I know it's a big word, but it's actually what you have on your cell phone. It allows your cell phone to know where your finger is. The green paddles are a little notched at the end to allow for entry into soil. They're arranged in a pattern so that when roots grow, so the seed is placed in that middle part at the top, so down in normal 2 inches down, and then roots grow out, and if all they have to do is brush by one of those sensors, they don't even have to touch a sensor. All they have to do is move the soil in such a way that the surrounding capacitance is changed. So what do we get from this instrument? We get angles of roots, because we know where they're starting near the seed. We see them coming by at different locations of those 22 sensors are right on the paddle. And we get numbers of roots, we get overall root bulk density, and we get growth rates over time. And I'll come back to that in a minute. So go on to the next slide, please, Eric. This shows root trackers in the ground in an early trial in Chile. You see they go into the ground either by just pushing them down with your foot or using a gas-powered fence post driver. In this case, we've got drip irrigation in those black lines running across the top of the furrow. The next slide shows a little later in the season where we've got them coming up, and on your right there, these are the base stations. And the next slide shows how this works. So you've got root trackers down at the bottom. They send a radio signal to the base station. Base station uses a cell modem to send the signal up to the cloud, that is cloud storage, and then we can access that. We're getting signals from every one of these sensors every 5 minutes. So 22 sensors, 12 paddles, we got thousands of these in the ground. You would think that's a lot of data, and it is a lot of data, but it's nothing compared to what it would be if we were trying to take images. So we get high quality data of over time of how roots grow, their architecture, et cetera, and yet we get it in a very compact form as compared to anything that would use images. Next slide. Now we're going to go show you a little bit of what we've been able to see with a root tracker. So one of the first experiments we did, and this again was in Chile, so we decided to cut off the water, see what happens if plants are exposed to a water deficit. And down if you look at the B panel below the top graph, that's the actual watering regime. So we watered 2 sets of plants, and we're talking about 400 plants, 400 root trackers in our 2 treatment groups. So the blue line is the one that's just kept getting watered. You see that in the panel B, where watering continues on. The orange line is the one where we shut off the water. And what we were very struck by was it only took about a week after we shut off the water, and we'd only been watering every 3 or 4 days. So it was like it missed 1 round of watering. And we already see a difference in the numbers of roots that we're detecting. And that difference just increased over time the longer the water was shut off. Now you go down to panel C, the lowest graph here, and now we're looking at not time, but spatially. So on the left, we have the top of the paddles, that is the sensors number 1, and the bottom we've got sensor number 22. And what we're looking at is a time period in about a week after we started to see differences in root growth. And here is very striking that what we see, again, the blue on the top is the ones that continue to get watered, the brown on the bottom is the orange is one where we shut it off. You see that the only differences we see are in the top sensors. The lower sensors, we didn't see a difference. I have to point out that these things only go about 8 inches into the soil. So we're not talking about deep like a yard down or 2 yards down. We're talking really remarkably sensitive changes in root growth based on drying out from the top. Next slide shows, so that sort of whetted our appetite, and we asked, well, are there differences even among different hybrids? And here you can see, if you look down that panel E, you see that the hybrid at the top, now we're looking at individual plants. And these are hybrids that we've either are selling or have sold in the past. The one at the top has pretty much the same pattern as the average. That is, we shut off the water and big drop in root number. The right-hand side of that graph shows that, again, it's in the shallow part, not in the deeper parts of the root tracker. Now you go down to the second one, the lowest graph, and that hybrid just didn't respond at all. Shut off the water, nothing happened. Kept making roots, and you see that the depth profile on the lower right, no difference. The top of this just shows that for a bunch of different hybrids, we have a whole range of responses, from essentially no response to very dramatic responses. So then we went on and did a second experiment. It actually was the same year. This was about a year ago in Chile, 2 years ago, I've forgotten now, a year and a half ago in Chile. So go to the next slide, please. And this one, now it's a little more complicated. So let me walk you through this. The second panel is, again, the watering regime. We have 2 sets of plants, one that we just kept the water going about every 3 days, had a watering event. The orange, that was the blue one. The orange in this case, we shut off the water early on. that is after about 10 days, 2 weeks, and it had exactly the same response as the first case. That is, we made fewer roots. And then we said, well, what if we turn the water back on? Does it just has it just gotten a signal to say, that's it, drought's happened, I'm shutting it off? No, it bounces right back up to then making the number of roots that the one that we kept the water on all the time. Then we did another experiment, which we said, well, what if we turn the water off a second time? Same plants, same conditions, let's shut it off a second time. And we fully expected that it would drop, root numbers would drop again, maybe even drop further. So this was a big surprise that in fact, we got more roots at that second drought. And now, so that what Eric is pointing to, and even more surprising was now we go down to that bottom heat map. Now this looks like a mess, but let me walk you through it. In this case, top to bottom is depth. So higher up is shallow, lower down is deeper. Again, depth just in the root tracker. We're talking about 8 inches. And then along the x-axis that is left to right, that's time. In this case, the coloring, the shading, the lighter it is, the brighter it is, the more yellow it is, that means more roots. And I want to focus your attention on the right-hand side of the panel. That is when we had that second drought. What we're showing you there is at the time of that second drought, the plant that's making more roots, or the plants, I should say, the 400 some plants, they're actually making those roots deeper in the profile, in the root tracker. And so what we're seeing is something that we think is the equivalent of what we see as priming in the literature. Wheat growers know this. Some folks in the corn business know it as well. That if you have a stress early on, particularly a drought stress, your plants are actually better off because they respond. They're healthier for the longer term. And what we see here is they even seem to know what to do in that second drought. That is, they make more roots and they make them deeper. And is this hybrid specific? Well, I think you probably know the answer already, but that's in the next slide. Sure enough, we have hybrids like on the top, runs the average, that is, makes fewer roots when we shut the water off the first time, makes more roots we shut it off the second time, while hybrid number 2 there, not much of a response. If anything, the second time around, it makes fewer roots. And on the lower set, again, these are a bunch of hybrids that we sell. These are commercial grade, high level hybrids that you'll be hearing about. And you see everything from ones that make more roots to make fewer roots. So here again, we have a response, a set of responses to the most basic input that you can think of for plants, that is water. And these hybrids, the genetics are giving us lots of different responses, and we will only know those responses by having some way to monitor root growth. And the only way that we know of to monitor root growth over time at this stage in the field is with our device, the root tracker. Next slide, please. Now, the last thing I want to show you is that this is, no, I'm sorry, 2 things I want to show you now. One is that this is not just, doesn't just work on corn, same root tracker, same device. Now we're looking at beans, and here we had two varieties that, based on greenhouse trials, had made more roots, and then some varieties that, again, based on that same greenhouse trial, made fewer roots. And so our collaborators here said, well, what happens in the field? Well, once again, sure enough, the 2 at the top on this graph are making more roots, the ones on the bottom are making fewer roots. Very similar to what was seen in the greenhouse. The big difference here is, number 1, it's in the field. Number 2, you're able actually to see not just in-stage number of roots, but seeing root growth over time. Notice that the trajectory, that is the steepness of the curve for the 2 that are making more roots, it's a much steeper curve just in that first week, making a lot of roots, and then it becomes less, it's less steep, but they're still making more roots, and they're making more of them faster than that set at the bottom. So this, I think, just wanted to emphasize again, this is the only device that we're aware of that can measure root growth rates that you see and we do it at scale. We can look at thousands of plants, and we're using this every day to look at our own hybrids as well as in collaboration with other folks. And one of the groups that we're working with is on the next slide. It has to do with biostimulants. Many of you almost certainly have experienced what it is to put a seed treatment on, biostimulant, claim to do X, maybe it doesn't do it so much, maybe it doesn't do it at all. So this is one set of biostimulants that we think we're starting to get at the reason why there's such a variability in biostimulants. Notice on the left, we have these two panels, two different hybrids. Again, our high quality, high performance hybrids. There's nothing off patent or anything that's going on here. These are high quality commercial hybrids. One on the left, notice treatment A actually makes that hybrid have more roots, growing faster roots than the control. Look down at treatment C. If anything, that treatment is having a negative effect on this hybrid. Look to the right now. You see where the control is, the blue line. Now look to see where treatment A is. If anything, it's having a negative effect on that genotype, while treatment C is having a positive effect, and the most positive is treatment B. We are now in the process of testing our hybrids against a whole series of biostimulants so that we can tell you which biostimulant to use with our hybrids to get an effect where we know that we actually have scientific evidence that is having an effect. I believe that's my last slide there, Eric. So I can turn it back over to Bill.
Okay, Eric, am I coming through? Can you hear me? Great, thanks. Philip, thank you very much. And I think what you've all heard here on the call today is a very, very in-depth description and a broad coverage of what we're doing as a base platform technology. Where that hits the road and where that really creates value is our ability then to connect that information on root signatures, root behavior, root orientation, root characteristics, as well as root responses to stimulants, be they biological or chemical or synthetic, to connecting that with our genetics. And so what we've done is that we've focused specifically on non-GMO corn genetics for a set of market areas that have been outlined here on the map to your right. What we've done is we've studied very, very carefully which products are being sold in a fully traded form across the Corn Belt and the extended Corn Belt to know which genotypes are the strongest, the most productive, and bring the highest ROIs to growers in the fully traded form. And we've selectively identified and accessed the non-GMO forms of those hybrids. And so let's go to the next slide. We are focused on working with every genetic provider to get those non-GMO genetics. And so we've listed here the various partners that we have identified, worked with, built combinations with, to take exclusive or semi-exclusive positions across a range of products, either exclusive geographically, pedigree-wise, or application-wise. And so we have built strong relationships across a broad range of genetic providers, and these providers have given us corn genetics that we have tested over the last 3 years and confirmed performance, placement, and positioning, both above ground based on your standard sets of traits that you'd be looking at, as well as beginning to characterize those products, as we'll talk about, on what's going on below ground, in the absence of water, with water, in the absence of biostimulants, or with biostimulants. So next slide. This gives you an idea of where we focused most of our testing. We identified those areas where there's strong presence of non-GMO corn germplasm today. And then we've gone into third-party trials, state trials, first trials, and cooperative research trials. We've attempted to use the CROs for our internal product performance and product advancement, and then focused on these third-party trials, the state trials and the first trials, as marketing data for Jim to use, as he'll talk about a little bit later in the presentation. And so we've got a high density of coverage here. We've sampled a number of different products, and over the last 3 years, we've identified our products that we wanted to work with most directly. Eric? The results really have been I would say, exceeded our expectations. We knew and believed, Jim and I, from our 35 years collectively in this industry, my 35, his 35, we expected good performance, but the number of results that we've seen where we've finished on top with 105-day products, 114-day products, we're in the top 5 with conventional genetics. And so the thing is that we all know that in the industry, certain hybrids get sold. And by and large today, the hybrids that get sold are those hybrids that tolerate or accept or integrate traits most effectively. And so when you're fully traded, you get compared against other hybrids or other genetics that are fully traded. And typically what companies do is they bring those products to the market. We've focused on those genetics or other genetics that may not trait as well, but in a non-GMO form actually perform as well. And I think what you'll see here as you look at these results is that you go down into Clay County in Nebraska, and a 114-day product against every imaginable combination of traded product and a number of other conventional products wins the trial at 300 bushels per acre. And so the yield potential is there. And the genetics have proven themselves to us over the last 2 years. Jim or Eric, next slide. The first trials, similar results as with the state trials in the previous slide. We've gone into these trials. We're using these trials because, historically, everyone kind of wins in their own data. And we would decided that for us as a new company, a relatively unknown company, we needed to compete against the best in the most objective trials that we could find. And so as a result, we've been very, very satisfied with these results. And you'll see these products today, the 100-day, the 105-day, the 109-day are moving forward in our programs aggressively. Next, Eric. An example of one product I'd like to showcase today is a 105-day product that we're planning across northeast Nebraska, southwest South Dakota, northern Iowa, southern Minnesota, into Wisconsin, over into Michigan, across northern Illinois. This product has food grade quality grain, deep kernels, hardened to sperm, the right kernel sizing, and has for us across tough soils, moderately productive soils, and the highest yielding soils been a winner in every circumstance and in every case. Particularly this hybrid has a root pattern that we'll talk about a little bit in just a bit that is extremely well adapted to organic or transitional soil conditions. Eric? We see the geographic span, strong agronomic trait package, key characteristics or GDUs and so forth assimilated that we normally see with the 105-day, excellent test weight, full ears, population response, very good, and actually has done quite well on the silage side as well. So we can extend it really today. Here's the root, the next slide, Eric, thanks, is the cylindrical root shape. This is what our root tracker data. So using the root trackers that Philip just described, and I explained to you the use of those, we've characterized our product lineup. And what we've seen are dramatic differences between our hybrids for how they interrogate the soil around the seed for nutrient extraction, water absorption, and ultimately standability concerns as well. What we find in this 107-day, 105-day product 1071 is that it has a very aggressive root structure in a lateral sense, and then deepens that. And if you can imagine in an organic setting, this is ideal relative to where we put the fertilizer, where the organic fertilizers are located, where the water comes, where the water sort of resides because of the high organic matter content of that upper surface of the soil. And this hybrid has done extremely well across northern Iowa in a number of both conventional as well as organic. You'll see on the left, we compare against the best from Pioneer, the best from DeKalb. We put ourselves up against their non-traded products as well as their traded products. In this case, you can see that anything above 100 would be a positive yield result, and the moisture is, of course, drier or wetter. Next slide. State trial winner, this hybrid has come through for us. It won the Sheldon, Iowa trial in Northwest Iowa. It was the top conventional product across the Northern Iowa district. When asked, when we're talking to our genetic providers and partners about these products, what we're told is that your company is really the most aggressive in putting these into the trials and putting these into the tests and getting them out in a high quality form and allowing growers to see just the potential that non-GMO genetics represent and what they can bring. Next. So we then have gone one step farther, understanding that the non-GMO has its most value in the grain. In addition to being an alternative to traded products, an alternative herbicide regime, but we know that the grain is important. And this hybrid has been submitted to Bunge Center Field Program, grain millers, a number of others still under work today. You can see that test by 60-pound test weight, thins at a very low level, the density high, the percent hard endosperm 86. So we've done this third-party testing done by the Illinois Crop Improvement Association, but we've also submitted samples to the grain buyers. And so what our goal is to, in addition to position our products agronomically, is to position our products from an end use perspective as well, and connect then growers who choose to use HFG products with people who want to buy HFG products grain. And so what we're doing is trying to build closed loop systems with end users, downstream, major cooperatives, grain assimilators, to build out a system that enables a grower to know that if they maintain isolation, they maintain quality, they keep the identity preservation in place, that there's an opportunity for a substantial premium at the end based on a prearranged agreement or arrangement. There'll be some that we bought wildcatting, trying to see if they can find one, but there'll be others that will be parts of systems. So next slide. So Jim, I think I'll turn it back over to you and let you talk a little bit about the value streams and the commercial side of this prior to getting to our customer.
Yeah, thanks, Bill. So just the value streams that we as an organization have identified, and Bill's touched a little bit on this, but really it's around 5 key value streams: that regenerative and organic value stream, and we've identified CRM range of 92 to 105 and have some very solid hybrids that perform in that segment. We have identified the export food grade segment that really covers the river markets, and we've got products that range in the relative maturity range of 108 to 114 days. Then we have the domestic food grade segment that Bill mentioned when he talked about 1071, 1051, and those hybrids. And we think that that's in the 105 to 114 CRM. Then we have some exciting hybrids that fit that distillation market down in Arkansas, Tennessee, Kentucky, that growers are looking for as they partner up with folks like Maker's Mark and Jim Beam, a couple of my favorite companies. And then that livestock and poultry market that's also in the South. So very targeted where those value streams are, and finding differentiated products that work extremely well and solve that solution of providing a better return on investment for growers. Eric? So as mentioned, Bill's covered a few of our products, but our portfolio really goes across a wide swath. We didn't add a ton of products, but we cover a lot of maturities. And so we go from really the Dakotas with the 83 RM all the way down to the 114 RM, and have exciting products that work very well. Several of them have made food grade and offer an additional opportunity for a grower should he put those on his farm. So we're going to turn it over now to Ben Adolph. Ben is an agronomist with Emerge Organics over in Western Illinois. And Ben's going to speak a little bit about the experiences that he's had with our products in his operation.
Yeah, thanks, Jim, and the rest of the HFG crew. So our farm is located in Northwest Illinois, smaller farm in terms of the size of farms around that area. But our focus has always been on, looking at the conservation side of our practices and putting more energy into the value and the quality of what we're producing. And for that reason, that we were kind of led to High Fidelity Genetics because of the focus on the quality of the product that they had. And it wasn't just a catalog of corn hybrids. It was an opportunity to connect with the resource directly, being Bill and Jim, and even having a couple conversations with Philip on the root tracker side of things, and Eric, of course, helping out a great deal. But really for us, it was how to have the opportunity to participate in a much different marketplace, and a marketplace that appreciated value, appreciated the effort to produce a food grade crop, but also maintain quality in our feed grade crops on the non-GMO side. So it's with High Fidelity Genetics and the products that they're putting out, I think the key thing is that there's not 100 different options. For me, it was very clear they knew what to plant, where to plant it, and the information they had behind those hybrids was exactly what I was looking for as an agronomist, not just a farmer. It was a little more technical, it was a little more direct. And what we appreciated about those hybrids is when we plant the food grade hybrids, we don't sacrifice, the typical production deficits that you might get out of some other food grade genetics. For us, it was a value add market, and it maintained production, as good as our non-food grade products that we were producing. And we started off using HFG in a cycle of about 6 to 8 other hybrids, depending on which one of my dad's buddies picked up a dealership. So now we're full on HFG, and it's two things. It's the production is there for us, as we don't have an opportunity to even put food grade corn into a food grade market that's close and makes sense on freight. So we're growing these products as non-GMO hybrids because they produce and they keep up and exceed yield expectations versus other hybrids that we're using. And we were using some fully traded hybrids the last couple of years just to maintain some issues on my dad's operation. But that's my key takeaway from working with High Fidelity Genetics, is that the production is there. If you're a good corn producer, these are great hybrids. If you're a mediocre corn producer, these are great hybrids because they're resilient on top of that. And so I think a conversation I've had with Jim and the rest of the crew before is my dad went on vacation this summer and totally forgot that we needed a Y drop corn, and 30 units of N goes a long ways at the end of the year, especially when you're 30 units short. So we had a little bit of a yield loss, but we noticed that we were using 107 primarily for that, but we had a little bit of yield loss. Obviously we were short nitrogen, but the ears flexed just like they were supposed to flex. We filled those ears out. The bushel weight was around 58, and we were also dry for 45 straight days. So I mean, just a phenomenal experience under distress is the best I could describe it. And we've had 2 very difficult years. I mean, we only planted 50% of our acres in 2019. And, even in that year, as hard as it was, HFG stood higher than, and that's when we had 5 other hybrids up against it. And the genetics we had from High Fidelity Genetics just, they overpowered everything we had it up against. So it's been a great experience for us as a grower. And I can tell you from the agronomist end of it, and the reason my company likes to work with High Fidelity Genetics is because the technical side is there. That closed loop system is a huge part of our company's focus at Merge Organics. So the opportunity to participate in a closed loop system, like Bill just mentioned, is huge for us.
Great. Thank you very much, Ben, for your comments. And again, we value you as a customer as well as a promoter for us out in the marketplace, getting the word out. So now we want to open up to our panelists. And Eric, I think you'll turn everybody on so that they can ask a question. But I'd like to start with a question for Bill and just ask him to comment a little bit on your and our company's testing program for 2021. And if you want to talk a little bit about our approach on genetics and on the hybrid side, and then maybe touch a little bit on the root tracker testing that we have along with Philip for 2021.
Sure, Jim, thanks. Everyone on the call, I laid out for you sort of our philosophy on sourcing. It is to get into modern genetics that are current, perform well, and are tested and true. Then identifying the purest, highest quality seed sources of those same products in a non-genetically modified form. And then maintaining that quality through the conditioning process by putting on the best organic seed treatments available, the best inorganic seed treatments available, or leaving them untreated as our growers prefer. We then follow that up with deep research to ensure that our non-GMO versions of these products are not available in certified organically produced forms, so that should a transitional acre or an organic acre want to use that product commercially, we can provide a letter to ensure that their certifier will enable them to certify that grain as being certified organic. We are committed to a strong presence in both the CRO, the state trials, and the first trials again this year from Nebraska, Iowa, South Dakota, Minnesota, Wisconsin, Illinois, Indiana, Arkansas, Missouri, Kentucky, Michigan, to really look at again, where are these products performing? We have a very strong lineup today, but like any lineup, it's alive and evolving. We've identified a few areas that we want to put some new products into. We have some exciting new 60-pound plus test weight non-GMO offerings that bring unparalleled quality, grain quality to the market, combined with test weights that just totally rock. And we are putting those out now in the areas where they have exhibited the strongest agronomic performance possible. This summer, we'll be running an extensive characterization trial again across multiple environments, from the Western Corn Belt to the Eastern Corn Belt, testing again and characterizing again and developing an even more enhanced root signatures for the way in which our roots interrogate and accumulate both nutrients, water, and micronutrients as well, and then their reactions with biostimulants. So we've got an aggressive experimental program in place again for this summer to further enhance the data knowledge, the data quality that we have around what's happening below ground, in combination to what we're doing and our partners are doing at evaluating those hybrids above ground. And so, Philip, I might let you say a little bit about some of the work that we're doing with critical partners across the industry.
Yeah, so we have been fortunate to be working with some of the top players in the industry. I won't name names, but these are among the majors. And with some initial trial runs last summer, they've come back and are really anxious to expand out the use of the root tracker for their purposes, including breeding, biostimulant analysis, et cetera. So we're very excited about the opportunities going forward this summer, and we expect that we'll be getting a lot of additional information. Would mention or repeat what I said is that we're also testing with our own material a number of biostimulants, and we're testing them across a large number of hybrids so that we can make that call and help the grower with making combinations of our genetics along with a particular biostimulant that we can tell you really does work.
Got a question on the line here from one of the attendees, and the question is, what guarantees do you have on GM levels in your seed? Bill or Jim, would you want to speak to that?
Sure, I can, Eric. So thank you very much, Bruce, for A, participating today, and B, for your question. So we test everything independently for GM presence, and our minimum level that we bring to the marketplace is 99.1%. And these are backed by an independent test.
And Greg, you have your hand raised.
Yeah, hi. Thanks for doing this town hall. I really appreciate it. Question, in the presentation, you mentioned that you're using the root tracker technology to identify variances and for various biostimulants and drought and how these various hybrids perform. Will that continue to be the focus of how you use the root tracker for biostimulants and drought, or will there be other factors too, like maybe corn borer or other corn diseases here? Like how do you plan to use this technology going forward here?
Yeah, thanks so much for that question. I guess I can take that in part. I mean, we view the root tracker as sort of at the very, very early stages of what we can use it for and how we can use it. We would very much like to, and the plans are to expand to different soil types, different stimulants, different stresses. And we think that it is really the one way that we can start to understand how different genotypes respond to with their root systems to all those different situations. Excuse me. Bill, do you want to add something to that?
Yeah, I think that, thanks, Philip. You know, I think, Greg, it is, we know that we're just on the front edge of understanding the interactions between years, environments, genotypes below ground, the way we've spent 100 years looking at it above ground. And which makes this so exciting. It really, that what we're learning is, you know, we're in that logarithmic phase of growth of what we're learning every year about how plant roots operate. And, you know, similarly, the way we did in the early days of plant breeding in the early 1900s, late 1800s, we were, you know, beginning to understand the power of hybrid vigor and the power of creating inbreds and combining those inbreds. And so then we've studied more recently how hybrids interact very differently in the presence or absence of a foliar fungicide, and how not every hybrid responds to a fungicide in exactly the same way. And what I think Philip's research is starting to point out is that, my goodness, that, you know, we're seeing the same sort of response below ground when we put in a either synthetic or biostimulant, synthetic or bio seed care product. And, you know, the idea that there would be a prophylactic effect that would treat every hybrid the same doesn't seem to be holding. And it has huge implications for how we might think about fertility and how we might think about water use efficiency. You know, what would that sprinkler, how often would you take that pivot around the field if you were monitoring roots and root water uptake, you know, as well as above ground water transpiration? And so I think there's that. And then I think the other side that Philip talks to us a lot about is the exploding area on carbon and greenhouse gases, you know, and what knowing and monitoring and studying root behavior might tell us about our capabilities in sequestering and retaining and holding on to, you know, things that would have impact directly or indirectly on climate. So it you know, for me, it's kind of a plant breeder's dream to be able to have this entirely new data set on which to think about hybrids, hybrid performance, hybrid placement, and farmer ROIs and on-farm income in a very different way.
Yeah, thank you, Greg, for that question. Any other questions from the attendees or any other folks?
So Eric, I make one last, maybe a comment from my side, just to, you know, having been in the industry for 35 years and a part of great organizations as Jim has, the industry kind of works on a linear business model today. That is, we develop a product, we manufacture that product, we own that inventory, and we sell that inventory to a customer where we hope the results will meet expectations or exceed those expectations. That is a tried and true model, and it's working, and it's being done with farmer sales reps, seed advisors, retail chains, and various ways. One of the things that we're interested in, I'd say to the audience, is to rethink that model and then try to understand how we can bring forth the best genetics possible in a way that addresses farmer risk. Okay, so how do we do that with the right biostimulant, with the right product placement, with below ground data combined with above ground data and above ground performance information, and then with other products that we might pull into the offering via open or closed loop systems. And so one of the things that's exercising our brains considerably here, in addition to the finding the right genetics and making the root tracker even more robust than it currently is thinking about new business models and how we could bring something to the market that doesn't exist today versus simply creating a slightly modified version of what's already out there. And so we'll do that with our partners. We have a certain amount of intellectual capital within the HFG organization, but we're made stronger by our collaborations with the Ben Adolphs of the world and people who are out there, the practitioners, the people who are, finding a way to make farming more profitable and make farming more sustainable, and as an industry and as an occupation.
And so we have one more question out there that just came in from Joe. Thank you, Joe. And I'll direct this one to Jim, because I know you spent a lot of time thinking about this over the last few months and years. What are the plans for seed distribution in the Midwest? Online ordering, seed dealers, or what's the plan?
So Joe, thank you so much for your question. Not sure where you're located. Right now, you do have the opportunity to order online. You can go to highfidelitygenetics.com and place an order. Our minimum order online is 10 units, but you can absolutely place an order right away online, and we will take care of that for you. Our distribution today, we are working with 2 partners, one in Nevada, Iowa, and one in Cuba City, Wisconsin, and they do our distribution for us. We do not have, this is really our 3rd selling season. We have not established a dealer network just yet. We are still looking at different models. We've done a lot of sales direct, either myself, Bill, Eric, or via telephone line. So you can pick up the phone and call us as well. But we are in the process of flushing out what our overall distribution network and go-to-market strategy will be as we go forward, as we continue to expand. But thank you very much for the question.
Does anybody else have any questions? And if not, feel free to contact us afterwards on our website or via email. We have on the website, you can find an email to send us an email, or you can call us directly by phone as well. We are always here.
Yeah, Eric, there's a follow-up from Joe. Where is the seed being grown? So we work with partners here in the Midwest, Joe, so all of our seed would be grown here in the Midwest.
Iowa, Illinois, Iowa, Illinois, Indiana, Michigan. And Wisconsin, of course. I'm sorry. Yep. Sourced locally and grown both in the isolated positions and isolated conditions, ensuring that we can hit that 99% or higher purity level on non-GMO. And Jim, I think we share that result. We share that data. One of the things that differentiates us as well is that that when asked by a grower, we will provide them with what the test results are on that seed.
Absolutely. And each of our product descriptions is also listed on the website, along with our key agronomic characteristics and really areas of adaptation. Good. Well, if there's no more questions, once again, thank you everyone for joining us today. We're almost at our hour. We appreciate your time very much, and wish everyone a very good planting season in 2021 coming up. And if you're, as Eric mentioned, if you're interested in taking a look at High Fidelity Genetics, please jump on the website or give us a call anytime.
We do have one more question real quick if you want to address it. As you grow, from Joe, once again, a follow-up, will you be looking for seed growers and plant locations?
That's a good question. I hope the answer is yes, Joe. We get to a volume where we can have dedicated seed production and get some growers that are uniquely growing just for us. As Bill mentioned, he and I both have over 35 years of experience in the seed business, and we know all about seed production and where it makes the most sense and how to manage a supply chain for seed.
Good deal.
All right, very good. Thank you, everyone. Have a great weekend and appreciate the time today.
All right, thanks, guys.
Thank you.